Well, great. My name's Tom Ball. I work for Google, and I'm one of the people that are working on the J2ObjC translator, which is what this talk is about. A little bit about myself. I've been with Google for 6 years. I'm not a compiler guy. I'm a developer productivity person. That's the thing that really gets me going, partly because when I can't develop at the speed that things are coming through my head, it's very frustrating. And I've seen that in my coworkers, and in some cases, it's easier to write a tool than it is to keep banging your head against the display. So over the years, I've created a fair number of tools. Prior to working at Google, I was at Sun for 14 years. Started on their, I know, I'm ancient. I'll stop at the resume for that, so you guys won't feel just how old I am. In any event, I joined the JDK team when it was called Oak. Java had to be renamed because of trademark things, and I came in about a month later, and they came in and they said, "What do you think about Silk as a name?" And I said, "Oh, God, that sucks." And they said, "Okay, well, third up is Java." And then the other one was Netrunner or something to that effect. I forget. Ghastly. So Java won, and I'm happy for it. So I've been in there from the beginning, and the reason we got into Java wasn't to create a language. It's because tools. We wanted to get products out the door, and the tools and languages that were there beforehand were keeping us from getting that. It was an impediment. So one of the reasons Java's been somewhat successful is that people have been able to ship stuff with it. And so we're hoping to take that same idea and apply it forward. So what is Java-C? Well, it's not going to be one of those talks, because the last thing I think you want to hear is some compiler geek come up and just go nuts about something that's actually not as important as what it's really about. And that is, our goal with J2ObjC is to share Java code across platforms. Ray Cromwell mentioned that in his talk. BigTop, now called Inbox for Gmail, and Google Sheets, and several products to be soon announced, are using this same development methodology, if you want to call it that, where we take shared code, the code for our business logic, code for our data models, transport code, and we share that across GWT, Android, on the server, and now in iOS. So it's all about the code sharing. So, and a second part, and the reason that I reaffirm that is because it's concurrent platform releases. One of the things you might remember from earlier Google products like Gmail and Google Sheets is that they came out in different releases, different versions, different bags of stuff, depending on the platform you were on. And there probably aren't any program managers here or product managers here, but let's speak in their words for a little bit so that you can remember it and speak back to your folks. And that is, it weakens brands. If a brand doesn't mean a single thing to your customers, then it's going to get fuzzy. And as it gets fuzzier and fuzzier, it starts to fade into the background. And other apps that are more strongly branded are going to come into their, attention. So we wanted to make sure that when you get Inbox, it's basically the same. When you get Sheets, if there's a bug in your calculation engine, it's going to be a bug across all of the platforms. And when we fix it, we turn the crank, and depending on App Store releases or what have you, it's basically pretty concurrent that you're going to get a fix out to all your customers. And why am I here? Because conceptually, where we started this was you could think of this as a GWT, or more realistically, a GWT compiler, for iPhones and iPads. Okay, so I told you what it's for and why we did it, but what is it? We call it a transpiler, and we didn't think that word actually existed until we found it on Wikipedia. So it's a translator and a compiler bound together. So you combine that with a runtime for iOS apps. And because this is a GWT conference, all of you are going, yeah, we've been doing that for years. We translate Java into Objective-C during the build. We focused, as I said, on shared data models and business logic. We're looking for code that is shareable. We're not interested in creating code that is write once, run anywhere. I tried that for 14 years. It didn't work that great, at least on client side. It's open source, and we use Apache 2 license. And then, as I said, it's used by products in-house. We also have a page that lists a lot of products that use it externally. And there are a lot of products that haven't told us yet that they're using it, which is fine by us. But you can sort of tell by the sorts of questions we get on the support lines and stuff. It's like, oh, okay, so-and-so from this company is asking a really detailed question. They're not just kicking the tires here. They're in deep. So what isn't J2ObjC? This is important because everyone just takes the name. It's a horrible name, by the way. I admit that. We never found a better one. So if you come up with a better one, that's great. Maybe you can rename GWT at the same time, because I heard that discussion in Ray's talk as well. But it's really not about Java and Objective-C. We're not looking to develop apps from a single code base. In particular, we stay far, far away from cross-platform UI support. Why am I so adamant about this? When I was at Sun, much of my work was on the Swing toolkit, and prior to that, the AWT. We tried really hard with some really smart people for a very long time to solve cross-platform UI. And the feedback we got from customers was that anything short of perfect is useless, because any poor fidelity in the app reflects back on the app. So rather than saying, oh, well, it doesn't quite work the same as your apps that are on your device, but that's okay because it's just as good. And they'll say, no, it isn't. It's buggy. Even though those bugs are just an issue of not being able to find abstractions that can be applied all across all platforms. So we don't bother. It's not a Java emulator. Like GWT, there is no Java in your app at the end of the day. So they were calling it, in the last couple talks I saw, a hybrid app approach. I actually take issue with that. It's a hybrid source code, but what comes out is a pure native app. Just like on your web app is pure JavaScript, at the end of the day, when what's running on the customer side, on an Android device, it's pure Java. On an iOS device, it's pure Objective-C. So for iOS, we compile the object files and we link it into the app. It's not for one-time source translation. I see people sometimes check translated files into their source repositories, and then they say, well, I'm going to report this bug that was from a translator 6 months ago. And we say, thank you very much, it's already fixed. And by the way, stop doing that. Because the Objective-C, and this is why the name is such a problem, the Objective-C is actually just this brief transient thing. You're welcome to look at it, partly so that you know that what you're doing is what is intended, partly for debugging, and partly so that if you can come up with a better idea for how to translate a particular expression, we're definitely open to hearing it. But the goal is to go from Java code and just build until it's in an application. And so we remove comments, the output's different. But what is supported? Right now, we support the full Java 7 syntax. We'll be supporting Java 8 about a little while after Android comes out. And the reason for that is because we use a lot of JRE code from Android. It has inner classes. It supports enums. It supports annotations. Not a big deal, you might think, but then when you think about enums, it's not C enums because Java expects them to be types, and we have them as types. You want to be able to say, oh, okay, well, what are the annotations that are on this? And it'll tell you. We have static variables. Again, doesn't sound like a big deal, but Objective-C doesn't have them. We support almost full reflection. And I say almost because I haven't gotten around to doing type parameters yet. There's a couple people who, or a couple of projects that need it, so we'll add it. Once that's there, we'll have 100% coverage on the reflection API, Java reflection. We do support dynamic code and resource loading provided, and this is on iOS, provided it's all in your linked application. So the classes have to be there. They just don't necessarily have to be loaded at that time. You can load them, but iOS requires that everything be part of that application bundle for security reasons. You can also load the resources just as you do with the Java Resource API. We support a JSNI style method of embedding code. I'll talk about that in a little bit. Basically, instead of embedding JavaScript, you embed Objective-C. So how do we use it? To translate Java source, just as a for instance, I'll also do a short demo, so you can actually see that it really is that simple. You run J2ObjC, that's the command name, on the command line or in Xcode. In Xcode, you can also define build rules so that you can actually say, okay, when you see a Java file, apply the translator, here's how you do it. And then you can plug Java files into your Objective-C project. And it has options similar to Java-C. So here's an example of a command line. You notice it takes a class path, it takes a source path, it takes an output directory, and they're optional. I mean, just like with Java-C, they have reasonable defaults. It has other flags, and we'll go into those, but one of the things we frequently get from people, they say, well, we're having trouble translating this thing. And you look at the output and you say, class path is wrong, or the source path isn't right. So a real easy trick to use, if you take nothing else from this, this is the one. Substitute Java-C for that J2ObjC command. Get it to work. Get it to compile cleanly. Then just switch it back. And you've got, in most cases, all you need to do for translation. So let's continue how we're using it. How do you compile the transpiled source? We have a J2ObjCC on the command line for the C compiler. And any option that it's just a shell script. And any option that it doesn't know about, it forwards to Clang, which is the C and Objective-C and C++ compiler for OS X, for iOS and that. So here's an example. We're calling CC, we're saying just compile it, don't link it. That's what the -C flag's for. -G says add some debugging information, and then the output directory is from the previous command. That's where we wrote the file to, and then we just add it. And Xcode just works. We have instructions. You basically add a build rule, and then you just plug in Java sources. So let me do a little demo. And rather than do something fake with a couple of foo and bar files, which I'll do in the next demo, we're going to port the Hamcrest library. Anyone familiar with Hamcrest? All right, you guys are writing a unit test. That's a good sign. So, if we look where I am, you'll see that I downloaded the source from the Hamcrest source repository. And we're going to do the core. So let's see. I'm going to cheat just because of the typing. So the first command I'm going to run, and you see why I didn't bother typing all this in, but can folks see this, or should I make it a little bigger? Bigger. Okay, let's see if we can get something legible here. How are we doing? Keep going? Okay, keep going. Better? Okay, that's it. Everyone else move forward. And consider getting your glasses checked, because all of us are spending way too much time in front of a monitor. And after doing it for so many years, it does affect your eyes. Don't believe what they say. Okay, so we have a J2ObjC command. We specify an output directory, as I said. We have a class path. Hamcrest defines matchers that are used for JUnit tests, and so it has a dependency on JUnit. No big deal. Source path. What we're doing here, we're going to translate it all in one pass. So we need to be able to tell the translator where you're going to find dependent files as you're in the process of translating this. And so, like most Apache-style projects, it's in source main Java. Then we run a find command, and all it does is, oh, I see we have a double here. Let's, oh well, it's okay. Ignore the line on the bottom. It's just a display artifact. And so we're going to find that same directory, all the Java files, and translate them. So it takes a moment, and it runs through, and it translates all the files it found. And we can look in our output directory. And you can see that it preserves the same directory path, so every Java file is going to have a matching .h file, header file, and a matching .m file. For those of you who are really advanced and are saying, how on earth can you support Objective-C++? Whoops. Hey, come on. And you see the .mm files. That's for the C++. Other than that, there's not a lot of difference. But the next step is we're going to go into the temp directory, our output directory, and let's run a cc command, similar to the one you saw me write. I'm going to say because we're in, well, let's show where I am. We're at the top of the root here, so I include a dot indicating that look for header files starting at this place. And then we'll do the same thing, only we're going to find all the .m files. And you run for a little while, and it not as verbose. But this is just Clang running. All it was a little script that just ran in, and so it's compiling the Objective-C files into all the .o files. And obviously, if you're creating an iOS app, you're going to want to add things like your architecture flag, and because you're cross-compiling to the various platforms. And so you just specify the same flags that you would in Xcode, and you can run it there. And that's pretty much it as far as how to create it. So a lot of people get really concerned about how do I use this? It has a steep learning curve, we admit. But the easiest way to start with it is to say, start with Java-C, get it to where you can build a thing by Java-C, flip the name over to J2ObjC. That'll give you all your .h and .m files. Then compile them with the -c and see if you have any dependencies, because those usually indicate that there are libraries that haven't been supported or something. But in most cases, it'll just build. So let's switch back over. Oh, actually, let's switch back for a moment. Let's look at one of these files. Let's say, where am I? Yeah. Okay, we'll look at base matcher. They're all the same. So, you see we generated the file. It's a normal looking Objective-C file. You can see a protocol forward declaration of a Objective-C class. That's the add interface. And then underneath, you see we actually are generating some C functions as well, and that's a performance gain. But one thing you might notice here, do you see how where it says attribute, always inline, inline void, org, Hamcrest, base matcher? What you're seeing there is name mangling. So let me go into that a little bit, because we were promised a deep dive. So default name mangling is to camel case the packages and use that as a prefix on the classes. The reason for that is because Java uses packages in order to create namespaces so that you can have the same name class in different packages. And Objective-C, like C, has a flat file system. It does not have namespaces like C++ does. So we preserve those names, and here's an example. Java util-q becomes Java util-q. Inner classes we append with an underscore, including the anonymous classes. So if you see some classes with underscore $, it's an anonymous class. And the file names map directly as I showed you. So basically, if you have a file Java util ArrayList Java, it's going to go out put as Java util ArrayList.m and .h. And that's because most build tools are pretty simple. They want to match patterns that say, for this file in, these files come out. Okay, why are we doing this again? There we go. Methods also get mangled. And here's the problem. We are designing this to be able to build essentially static libraries for iOS. And so there's no guarantee, unlike with GWT, that you have all the source code available at the time that you're building the final app. We don't require that. So as a result, you may not have all the symbol information that you do have from Java source. And Java class files have types for parameters. They don't necessarily have names, although for Java 8, that's going to get a little more common. And method overloading is used. So you can't just go by the method name. So a solution, which is not something we came up with, but is a common for translators, is to embed the parameter names, the type information, in the name itself. Has anyone tried dumping a C++ file, .object file, and look at the symbols there? You have. Okay. Mangled? Yeah. What you'll see if you look at those symbols is the same thing. You'll see the type information embedded in the names. So we didn't invent it. Don't blame us. And it is ugly. And Objective-C developers, if you're Java developers seem to be pretty comfortable with it, but as soon as you show it to Objective-C developers, they just freak out. So be prepared. So here's a simple example. The size method becomes size. But if you, as soon as you start adding parameters, you have to embed them. Notice we're adding with an int and a float. If it's a type, it has to be a mangled class name. So now it's starting to get pretty long, even though we only have one parameter. So imagine if you've got half a dozen parameters with various different object types and stuff, you can get some really long method names. But we can always find them at compile time, and we can always link and be guaranteed there will only be a single symbol that'll respond to that. Okay. J2ObjC wouldn't be much, just like the GWT compiler, without having JRE runtime support. And as I mentioned, we're based on the Android source code. We did start out like GWT did with Apache Harmony, but in order to support Java 6 and then Java 7, we moved to Android. One nice thing is that they actually are being pretty good about fixing bugs in the Harmony base. And so we pick up fixes on a fairly recent basis. We've got almost 2,000 classes now. I just ran a word count in order to find them. Some of the classes, but not many, have iOS-specific native code in order to tie it into the underlying systems. One example of that is security, which is a major concern for handheld devices, is that we use the iOS security framework, and it's about half done, and I'm writing security providers that map to the security framework. So not there yet, but coming will be certificate, key store, secure sockets providers. It's like the last part of Java security I haven't done yet. And we have over 4,000 JUnit tests. Why is it doing this? Yes, JUnit. We support JUnit 3, JUnit 4. And the way it works is you translate the test sources and you link and run the app. We're not emulating it, it runs on the device. So you can run your unit tests on OS X, which is fast, or you can create an iOS app, add your test classes to that, and then run your tests on specific devices. So if you have a concern about whether your code is working correctly for iOS, you want to make sure, I mean, one of the biggest things we want to make sure was that the semantics of the translated code don't change. It doesn't matter what the code looks like underneath, but its behavior needs to stay the same. And the way we enforce that is by unit tests. So if you're not sure whether or not there's an issue with the semantics being preserved, check your test. And if you haven't written the test, write it. And we use all the existing test runners that are in JUnit 3 and 4. I always use JUnit Core, but some people have written their own. And as you saw, we support the Hamcrest matchers. We also support Mockito. It was kind of nice, Jesse Wilson, who's at Square now, but was a Googler, and I worked with the Mockito team, and he was providing Android support, and I was providing iOS support, and so we decided the best way to do that is to have a plugin for a mock maker. And so there's a native mock maker that works with that. Okay, as Ray mentioned, we do have different memory options. We generate either ARC code, automatic resource counting, or reference counting, or manual reference counting code. We don't support GC anymore, and the reason for that is because it's never been supported on iOS, and it now has been deprecated on OS X. So it's easy enough to generate the code, it's just not going to do you much good once you have it. And we use manual reference counting inside the JRE because we found it to be a little bit faster for certain types of operations. Odds are you won't have to, and so generally we recommend using ARC as a default. That automatic stuff, you don't have to worry about the reference counting nearly as much. And then if you run into a performance issue, at that point you can turn off ARC for specific files if you wish. One of the things that Ray also mentioned is that one of the problems with reference counting is the possibility of having cycles. If you have class A that references class B, has a field of class B, and class B has a field of class A, you create one of each, and all of a sudden, they both have a reference count of 1, and so they never get released. And so the cycle finder does static analysis over your Java code, and we'll find that. So you don't even need to, you can actually run cycle finder on your existing code today, and it'll report on areas that are perhaps, in some cases, indicators of a better design could be used. We also support annotations in order to break cycles that cycle finder finds. So there are two cases. If you get a report that there's an error, you can whitelist it, say, I don't want to see this anymore. It doesn't matter. Everything's good. Or you can break the annotation by making one of the references weak. And that translates directly into a __ weak and attribute in Objective-C. So let's take a quick look at that, because I don't know if it's still true, but for a while the #1 FAQ was, what about garbage collection? And the answer back was, it's not about garbage collection, it's about managing the memory that your app uses. Garbage collection is a solution, it's not a requirement. So if you have an alternative solution, use it. Okay, let's pump this up. Okay, as I promised, I've got a couple of fake files here. We've got your foo.java that has the reference to bar, as I mentioned, and in bar.java. So there is a cycle. If you create one or the other, it's going to automatically pull in the other, and the references will never be released. But we didn't notice that when we designed the classes, so let's run Cycle Finder on it. Oops. And it found the cycle. It'll also find some really obscure ones. So this isn't a toy app. It's actually quite sophisticated. I had nothing to do with it, by the way. My co-worker in Waterloo, Keith Stranger, wrote it, and it's phenomenal. It's really made a difference between shipping inbox and not shipping inbox, even though there were only a few areas that had cycle issues. So how do we fix this? Well, one way is to whitelist it. So let's look at the whitelist. So here I've just said, okay, when you see the field in mumble bar myfoo, ignore it. And now that we've run it, we say there are no cycles in there. But what if we want to fix it? So let's go into, let's say bar. And sorry, these are so long, but what can you do? And then we want to say, okay, so what we're saying here is that make a weak reference to myfoo, and that way when we release the main foo that has the reference to bar will also get released because there isn't the reverse. And now when we run Cycle Finder without the whitelist, we have 0 cycles. And if you're looking for, I mean, if you start doing this and it gets a little overwhelming, just look for weak and weak outer in the JRE source, especially in the collections classes. Collection classes love to get themselves all bound up, both Guava and JRE. But take a look and you'll see some examples of how it's used. Okay, well, no tool is finished. So what are we planning in the future? First off, we want to support dependency injection. It actually works today for a couple of different platforms. The main restriction is it can't work with platforms that generate bytecode and then dynamically load it because it's not a Java interpreter. So that excludes Juice. But we ran into the same issue with GWT, so some of the dependency injection libraries for GWT may work if they're not dependent on native JavaScript. So, but Dagger 2, as Ray mentioned, has been designed to be able to work on GWT, Android, and now iOS without any runtime reflection requirements. It's really pretty slick, so we recommend you check it out. The next thing we want to support is protobufs. As Ray mentioned, we use them internally for all of our apps because Google loves protobufs. And we use protobufs for, actually, let me ignore that line. I thought there was a bullet after that. For protobufs, as he said, you normally take a protobuf compiler and then you generate for the specific backend. And what we do is we generate for J2ObjC code so that we get the names mangled correctly. And that way we don't have to write that wrapper that he was talking about, which adds overhead. And instead we write directly to the protobuf and we get much better performance. So that we hope to be releasing that hopefully end of this quarter, maybe early next quarter. It has more to do with the open source gods and lawyers and stuff rather than any technical issues. The next up we want to support are the Google REST APIs. Most of the services you see in Google, like Maps, Calendar, what have you, you can access through a REST API. In order to do that, though, you need to have we have a Java library that gives you access to those APIs, and it requires HTTPS, which I'm working on, and OAuth, authentication. And so we'll have those in there, and then once that's in place, we'll be able to have the library to give you access to the REST APIs. And we're constantly working on performance. Just today, Keith checked in a change that made instance of 3 times faster. So we're constantly grinding on that, because even though the biggest performance gains are in the application by choosing correct algorithms and correct collection choices, still part of a compiler writer's job is to keep grinding away at performance. So to do that, we want to eliminate Objective-C messages. One of the things Java developers may not be aware of, even though they've been defending it for 20 years now, is that Java is actually really fast. In particular, the Java method invocation is faster quite a bit than Objective-C message dispatching, even though Objective-C has also had actually 30 years of optimization work on it. And the reason for that is similar to why JavaScript is slower. It's because both Objective-C and JavaScript are more dynamic. And so you can't rely as much on what's done statically in order to be able to optimize methods. So the way we get around that is we eliminate messages where possible and use C functions instead. We also want to get rid of null and index checks wherever they're redundant, but make sure they stay in place wherever they're necessary. Objective-C, a little gotcha for new-time Java owners, is that if you send a message to a null reference, it'll quite happily respond give you an answer. So if you've got a Boolean message, you send it, it'll say false. If you say, an int value, it'll say, oh, the return's 0. So you think you have a valid reference, but it's 0. It's null. And instead of getting a null pointer exception, it just blithely runs along, which is good from a performance standpoint, but really bad from a semantic standpoint, because now that shared code isn't doing what you thought it would. So we add null checks and index checks, and anytime you add a check, it adds a little cost. The important thing to remember about this list is that none of what you see here is cast in stone. We really work very hard to respond quickly to client requests. Obviously, our first clients are the people that pay our salaries. So those would be the folks in-house. But one reason we're so actively engaged with the open source community is because in many cases, the open source community tends to be an earlier adopter, and they find stuff before it's going to hit us in the back end. So before I've got 100 Google engineers that are going to walk over to my desk and lean on me, someone out in who knows where sent a bug report that says, oh, I found this issue. So we often wind up fixing problems before those engineers can come over and twist our arms. So it's a really nice balance. And that's one reason why we're really happy to stay engaged with the community. We encourage your participation, and we also take fixes. The last thing you might be interested in from an open source perspective is that it's fun. Working on a translator is really fun. If you haven't done it, give it a try. You don't have to be a compiler guru. You don't even have to have taken a compiler course in college. It helps, but it's not required. Just jump in there, because one of the cool things about a translator, as opposed to a hardcore compiler, is that the output you can read. And so even just simple things, like if you're in the generator, you can just, hey, it's supposed to look like this. You can just go in there and type it and run it, add a unit test, boom, all of a sudden it works. We can go really fast in terms of developing translator improvements. And we have a lot of fun doing it, and we encourage other people to jump in and have fun as well. So, more information. We have 2 sites, J2ObjC and GitHub. Actually, I lost my page, but. So this is a pretty simple site page that we're going to be expanding on as we get along. And then all the real action is over in our GitHub repository. And so you'll find over there we've got a wiki with a lot of documentation for a two-man operation, and issues and everything else you need in order to be able to pull it down and start building. And all the source code is there. We're not holding anything back. We also have a discussion group email, and we do respond quickly to Stack Overflow questions. And with that, I'd like to thank you all for listening. I haven't heard a single stomach growl, which is wonderful. And with that, I'd like to open it up for questions if there are any.